Hi everybody, this is CR number 20, helper video number 3. So let's take a look. It says which equation gives the relationship between x and y in the table below. Okay, first of all, we have learned a little bit about our equations so far, and that they are always in the format of y equals mx plus b. Now, we might not have actually used all of these letters at this point, but now is a good time to let you know what they are. The M we talked about in class, and the M actually stands for the rate of change, okay? And that rate of change used to be known as a constant of proportionality, but now we're dealing with graphs that do not always start at the origin. So because we don't start at the origin, the unit rate cannot be determined, so we can't really call it that anymore. So now we call it the rate of change, and that's what the M stands for. In our equation, the B stands for the y-intercept. And remember, the y-intercept is where it crosses the y-axis. And if I were to look at a graph that looked like this, and this is my y-axis up here, any single point that I could draw on this graph, because I'm only from the origin going up or down, notice that the x value is always going to be 0. So if I were at this point here, that point would be 0, 2. If I was at the point down here, one below the origin, this would be 0, -1. So remember, your y-intercept is always when the x value is 0, and you need to know that because you're looking at a table. So if you're trying to find an equation that matches this table, the first thing you need to do is look at the y-intercept. The y-intercept is when the x value is 0, which is what we just talked about. So notice the y is 0. The y is 0. So if the x is 0 and the y is 0, the y-intercept here is 0. So the y, oh, that's a terrible looking I just drew. Hold on, let me change that. The y-intercept, int is what I'm trying to write, is equal to 0. And remember, when it equals 0, you don't need to add a 0 value because it doesn't exist. So if I look at just A, okay, right here it tells me the y-intercept is 5. So A can't be my answer. If I look at B, it tells me, well, first of all, the y isn't in front here, so B can't even be a choice because the y doesn't come first. Let's look at C. C looks good, and I know it starts. You probably know that's the answer. But before we determine that is it, let's look at D. D, we see that it starts with an X, so this one also can't even be part of the answer consideration. So my answer has to be C based on that elimination. But let's just double check our rate of change. Our rate of change, remember, is rise over run. The rise over run means rise is always based on the y, right? Up or down when we're talking about the y value. And over the run, and let me just write the words here, the run is always the x value and how that's changing. And that goes left to right, which is the x value. So based on a table, if we were to look at the rise, we need to see how much the y value changes every single time. Now the issue is here on this table that your scale on your x is not consistent. So what we have to do is when our x value is going up by 1, so my rise is 1, my run is 1, I'm so sorry, I'm mixing up my words, because it's increasing by 1 every time. Notice that the y value is increasing by 5. So my rise is 5. Now, then the scale jumps to 2 here. But let's go back down here where it jumps by 1. If it increases by 1, the y increases by 5. It is a consistent scale. If I were to put a -1 in here, it would only go to -5 here. If I were to put a +1 here, because that number was skipped, it would be a +5 here. So my rate of change is 5, and that always goes in front of the x, so that is the value.